And welcome. In this video, I'll be talking about estimating a population mean. So we're going to be using a confidence interval, and every confidence interval has the same two pieces. We're going to need a point estimate and margin of error. So, for instance, in another video when I was talking about estimating the population proportion, we used p hat plus or minus e. E is the symbol I'm using for margin of error. And but in this video, we're talking about the population mean. So for our point estimate, we'll use the sample mean. So instead of p hat, we're going to be using x bar. So that's the point estimate. So all we really need to do is figure out how we're going to calculate margin of error. So margin of error has two components. The first, we need a critical value that is determined by our confidence level. So I'm using just a C for that. And then we need a standard error. In this case, we'll be using standard error of the mean. So a little refresher, the sample mean is normally distributed, centered with the population mean, and the standard deviation is the population standard deviation divided by the square root of n. So this is the mean for x bar, and this is the standard deviation for x bar. All right, so we would like to, we're going to use standard error of the mean, and for estimating the proportion, we used a z-score for the critical value. We actually used z alpha over 2. Now, there are a couple of issues here. First of all, our goal is to estimate the population mean, mu. So obviously we don't know it, or we wouldn't be trying to estimate it. So now, if we don't know the population mean, we wouldn't have any way of knowing the population standard deviation. So we're going to have to make an adjustment here. And instead, I'm going to have to do a substitution. And instead of using sigma, I'm going to have to make do by using the sample standard deviation. A consequence of that is that I won't be able to use a critical value from the standard normal distribution. In other words, I won't be able to use a z-score because the z-scores for x bar minus mu over s over the square root of n, this is not normally distributed. Instead, it follows the t distribution. So I'll be using t of alpha over 2. So this is, let me just rewrite this to put it all together. So the way that I'm going to construct my confidence interval is I'll take x bar, my point estimate, plus or minus t of alpha over 2 times s over the square root of n. So when I subtract this amount, I'll get a lower bound, and when I add it, I'll have an upper bound. So my interval will look like this: x bar minus t of alpha over 2 times s over square root of n. And then for the upper bound, it would be x bar plus t of alpha over 2 times s over square root of n. However, let me show you a shortcut. If you have a TI-84 and you go to your, first I'll turn on your stat menu and scroll over to the test and then down to option number 8, and you'll see that it says t-interval. So when you select t-interval, your calculator can accept input one of two ways, either as raw data or by inputting summary statistics. So if you have the raw data, you would have to enter that into one of your lists, so maybe in list 1, and you'll leave the frequency here always set to 1, and you could input a confidence level, and then your calculator will give you the lower and upper bound for the interval. If you don't have the raw data and you have summary statistics, you'll highlight this, and your calculator is going to ask you for these three pieces of information: the sample mean, the sample standard deviation, and the sample size. And of course, you're going to have to put in a confidence level. So for instance, let's say that you have a sample mean of 75, a sample standard deviation of 8, and this is from a sample of 30. And you want to construct a 95% confidence interval. So I would change my x bar to 75, this to 8, this is 30, and then hit calculate. And you'll notice the calculator then will give me an interval. In this case, it's 72 and 77.98. I'm just going to round that to 78. So and I also want to point out the calculator also does give you the mean, which is the point estimate of 75. But that's kind of redundant because I already knew that. I actually put that value in myself. The reason that I want to copy this down again is to show that if you want to calculate the margin of error, then it's the difference between these two values. So 78 minus 75, which is 3. So the interval would be 75 plus or minus 3. And that's how we're getting 72 and 78. To interpret this, we can say that we are, let's see, 95% confident the population mean is between 72 and 78. All right, and one last thing before I finish this video. There are a few requirements, things that you should check before you use this technique. First of all, you want to make sure that your data, your sample data, is from a random sample. You'll also want to check to make sure that the population is normally distributed. But there's an or here. If the population is not normally distributed, or if you don't know, then you have population is normally distributed, or the sample size is large. And then the third thing that we can check is to make sure that your sample size is small relative to the population size. So in other words, we want to make sure N, our sample size, is less than 5% of the population size. Now, how would we know number 2 here? So there are a couple of tools that we have for checking whether a population is normally distributed. You might do a normal probability plot and just check, remember this looks kind of like a scatter plot, and you want to make sure that these things fall on or near a straight line. And sometimes you can calculate R, the correlation coefficient, and you want to make sure that that's at least as big as a critical value that you usually would look up. And so that's one test to see if this condition is met. And you also may want to look at a box plot. So, on a box plot you have markers for your Q1, the median, and Q3, and the box plot can tell you if there are any outliers. So an outlier is usually given a special symbol, and it would be beyond one of these whiskers. So if you have outliers, it may not be appropriate to use this method for constructing a confidence interval. So those are just some things you'll want to check. All right, that's it for this video. See you next time.